He's not gonna give us this. We're not ready for it. I don't think he's gonna give it to us next week either.
Yeah, I honestly believe that either Friday or
Are you talking about Solace?
Yeah.
Yeah.
We're not gonna have a test.
Okay. So if we'll just jump back. Why not? We'll do 69s first. We'll get both though. Find the current and potential difference across each resistor. Place. Huh? Oh, 69 is easy. We don't need that one, right? We do? Okay. Well, here's a condensation, right? We got 4, and then the 8 and 24 become 6 ohms, right? 1/8, 1/24, and then that 6 and 6 becomes 12. So we go to this condensation. This 12 and 24 becomes what? 1/12. What does it become? Does it become 12? No, it can't be 12. Oh, here we go. 8. Okay, good. I'm like, that doesn't work. They went over here. Okay, becomes 8, and then these two come together to become 12. Right? Now, once we do that, we find the current coming out of the battery because it's 24 volts, 12 ohms gives me 2 amps. 2 amps coming out of the battery. Now, what you want to do is take that current right away and see if there's anything that's using the current. Look in front and behind of the battery. If I look in front of the battery, there's 4 ohms. 2 amps, 4 ohms, how many volts? 8 right away. You see, does it make sense? So boom, I've got 8 there. Now, the beautiful thing is, you see what we just did? We just found 8 volts. Look at the loop rule. I can come through here, and now I know exactly how many volts are here. Because there's only one resistor back to the battery. Right? 24 minus 8 gives you, that means there must be 16 volts here. You see that? Now the beautiful thing about that is 16 volts, 24 ohms, what's the current? 16 over 24.
Yeah,
Isn't it V is I over R, right?
Yeah, I know.
Wait, no, sorry. V goes IR, so I is V over R. So I for this is V, which is 18 over 24, so it's 3/4, right?
18, that's 16.
16. Well, not 16. Okay, 16. Whatever. Okay, whatever this is. We find this current right here, and we could subtract it from the 2, and now we know the current here.
Wait. Why would you?
Okay, let me write this out. I think people are getting lost here a little bit. Okay, so let me write this out, and what I'll try to do is I'll put voltage in red, I'll put current in blue. So we know that this is we know that this is 2 amps going this way, 2 amps coming this way. Everybody cool with that? So 2 amps in 4 ohms gives us 8 volts right there. That means this must be 16 volts. Okay, and 16 volts over 24 ohms, divided by 4, what is that, 4 over 6, 2/3? So that gives us 0.67 amps, which means this must be 1.33 amps. See that?
Because both of them have.
Junction rule, right? Junction rule says that 2 amps comes in, 2 amps has to go out. If 2/3 of an amp went this way, then that means 1 1/3 must have gone that way. And now, if we have 6 ohms and 4/3 of an amp, then we have 8 volts, right? Everybody get that? Okay, so then we've lost, oops. So we dropped 8 volts here. Now this is a beautiful thing. Do I need to fart around with which one has more current, which one? No. That's 8 volts, that's 8 volts. How many volts do I have left? 8, for sure. So I know this is 8 volts and that's 8 volts. Has to be. And then I is V over R. So I know this is 4/3, right? 4/3 of 4/3 amps. So this is going to be how many amps? 8 volts, 8 ohms? Yeah, it's just 1. So this is 1 amp here. So this is 1/3 of an amp here. And bingo. Because we have 2/3, 1/3, 1, and that makes 2. Bingo.
How did you get the 1/3 amp?
Oh, because this was 1 1/3, right? 1.33?
Oh, it has to add up.
Yeah, see? Like, there's no weird proportions, no weird ratios. All I do is just say, I use the loop rule, the junction rule, and the loop rule. That's it. And just be smart about it, and everything works. Okay, now, I think they did that, but they did it. Yeah, so they go here, and they do pretty much the same thing. They get 2 amps, 8 volts, and then just use the junction loop rule all the way around. Okay, any questions there? Okay, so that's recorded.